In this example, we're going to learn how to rewrite fractions whose decimals terminate as decimals. Okay, so you may remember the word a decimal terminating or repeating, so we're going to talk about what that means first. If a simplified fraction can be written as an integer over a power of 10, then its decimal expansion terminates. So terminates means that it stops and the numbers don't keep going on forever. A decimal is a terminating decimal if its decimal expansion does not go on to infinity. So I have the calculator ready, and let's just look at an example of what it would look like on your calculator if you have a terminating decimal. So 3/4, we've looked at this already and we know it's 0.75, but I'm going to divide 3 by 4 and the calculator gives me 0.75. This terminates because the decimal stops at 5, and this is exactly what the number equals. But let's look at a different quotient. Notice here the decimal keeps going and going, and it would actually go on forever and ever and ever, but the calculator stops at some point. And if you notice, there's a repeating pattern. So 307,692, 307,692. So notice that pattern repeats again and again. And those are the two things that will happen when we have one integer written over another. So right now we're looking at the terminating decimals, and decimals that terminate, we can recognize them because basically their denominators are going to be powers of 2s and 5s. So we can rewrite them as an equivalent fraction with a denominator that is a power of 10. So let's look at some examples. I think it'll go a long way. So we have 3/4. So I'm going to start by writing the prime factorization of 4. So 4 is 2 times 2. Now, since we have a base 10 system and 10 is equal to 2 times 5, okay, if I can make this a power of 10, some number of 10s multiplied by each other, then I can easily put this in the chart. So since there's 2 factors of 2, I'd need 2 factors of 5 to make this as a number over 10. So I'm going to think of when we did this with fractions, we're cutting it into more pieces, so I'm going to multiply by 2 factors of 5, 1 5 to match each factor of 2. So basically you want a bunch of 10s in the denominator, but the smallest amount you need, you don't want to put extras in. So now since I cut the bottom pieces into 5 times 5, I need to do that to the top as well. Okay. So now let's multiply this on the calculator. You can do this in your head if you want. So 3 times 5 times 5 is 75. Let's see what 2 times 2 times 5 times 5 is 100. So we have 75 over 100. Okay. And notice the denominator should be a power of 10, so 10, 100, 1000, etc., because I use the number of 5s in such a way that each 2 would have a 5 pair, so this 2 times 5 gives us 10. This 2 times 5 gives us 10, and 10 times 10 gives us 100. So I intentionally made this happen so we'd get a denominator of 100. So in our decimal chart, this is 75 over 100, and in the hundredths column, and we have 0.75. And that corresponds to what we saw before. Let's look at the next one. So here we have 7 over 25, so I'm going to start just like I did before by writing 25 in its prime factored form, which is 5 times 5. Okay. And since it has factors that are only 5s or 2s, in particular this one just has 5s, this one has 2s, but as long as you have 2s and 5s in the mix, then we can rewrite it with no other numbers, just 2s and 5s, as a power of 10. So I'll need another factor of 2 for each factor of 5. So we have 5 times 5. I'm going to add 2 factors of 2, 1 factor for each factor of 5, and whatever I do to the bottom, I'm also doing to the top. And now we'll multiply. Well, this is 5 times 2 is 10, 5 times 2 is 10, 10 times 10 is 100. Now this is 7 times 2 times 2. Well, that's 4 times 7, which is 28. So 7/25 is 28 hundredths. So putting that in the chart here, 28 hundredths is 0.28. Let's look at the last one. Now this was the trickiest one when we drew the picture. And don't worry, you don't have to draw the pictures a lot, if ever. It's just a way to help us understand it. But let's see how this one's a little bit different when we factor it. So 8, let's make the factor tree, is 2 times 4, and 4 is 2 times 2. So 8 is 3 factors of 2. 2 times 2 times 2. So they're all 2's, but there's 3 of them, so I'm going to need to put 3 factors of 5. Okay, so I need one additional factor of 5 to match up with every factor of 2. Now we have the 3 up there, keep that, but we need 3 factors of 5 on top as well. And now we're going to multiply this out. Now I hope you can see, if we multiply the 2's with the 5's, this is 10 times 10 times 10, which is 1,000. You can check that on your calculator if you'd like. And then we have 3 times 5 times 5 times 5. 3 times 3 factors of 5 is 375. So this is 375 thousandths. So I'm going to go all the way to the thousandths, write the number backwards, and we have 0.375. So this one went out further than the hundredths place, and it's basically by looking at the number of factors of 2's and 5's. Okay, so we had 3 2's, so we needed 3 factors of 5 to pair with them, so that's going to go out 3 factors of 10, which is 1,000. So basically your biggest power of 2 or 5 in your original one, that's how many decimals you'll have to go out. So that's a nice fact to know. It's not necessary, but it's a nice pattern to see. Now we're going to look at some examples of decimals that do not terminate.